Brandon? Well, where do we get that OUS ending from? When we're naming acids, we use the OUS ending. We change that from some other ending. No. That's a whole different thing. Where do we get the OUS ending from anybody? Where does the OUS ending come from? ITE endings. Okay? So we're looking for something that has an ITE ending. Alright? And you said it was sulfurous? Okay, so what we want is sulfite. Where do I find the formula for sulfite? Huh? It's in the test reference. Which one in particular? You know which page it's on, or what section of the reference it is? We just used it a minute ago, or a few minutes ago. On the common ions list, it's SO3, 2 negative. And what was the other part of the name? Sulfurous acid. Okay. Well, then I need hydrogens on the front. Hydrogen ions are going to have a 1+ charge. The sulfite will have a 2 negative charge. So what prefixes do I need on those to get a 0 charge overall? 2 and a 1. So I need a 2 here, a 1 here. So the formula must be H2SO3. Yes.
The question that you mentioned as far as about the ionic compounds and powders, what was the name of that section there?
Covalent network compounds, or covalent network crystals. Either one is fine.
So H2SO3 is fine.
Correct. Yes.
When carbon atoms bond with other nonmetals, how does it still expand to electron up to the state of it?
Say that again.
When carbon atoms bond with other nonmetals, how does it still expand to electron up to the state of electron?
Okay, when you put two nonmetals together, what kind of bonding do you get?
So when you put carbon atoms,
Carbon's a nonmetal. So when you put two nonmetals together, how do they bond? Covalent bonding, which means what? What are they doing? Sharing electrons. Mm-hmm. So it's just kind of like you got to add a few little things together you already know. Carolyn? H3PO3. Okay. So then you go again to the test references, and you'll have this list on the test. Okay. And this is we're looking for the same list that I was mentioning to Brandon a minute ago, the common ions list. Okay. And you said H2PO3. Okay. H3PO3. Okay. So let's see. Let's find PO3 here. There's PO3 right there. Phosphite. Okay. There's PO3. Phosphite. All right. So I'll put that down on the paper. Phosphite. Okay. And then the H2 on the front, H3PO3. Whenever we have a formula with H's on the front, what is that? Huh? It makes it an acid, right? When I say, yeah, it's a hydrogen, but I mean, what does that make? What kind of compound is it with an H on the front? Okay, it is an acid. Well, how do you change the name of hydrogen phosphite to make it an acid name? We just did the reverse of this a minute ago when he asked about, huh? You do add acid on the end. What else do we do to the name? What now? Oh, ites become OUS. Okay? So, in this case, we're not only dropping the ite, we're dropping the pH too, just because it's phosphorus. And since it's an acid that has a polyatomic ion, the hydrogen goes away completely. So that becomes phosphorus acid. So I said drop the pH. That's when you're going about the other way. You drop the OR when you're going about the other way. You don't drop the pH. You only drop the IT. Phosphorus acid. Okay? Yes. Dipole? A molecular dipole is a polar compound. Okay, Kelly. Kelly, I'm sorry. Carolyn.
Number 40, what is the formula for palladium thiosulfate?
I heard thiosulfate. What is it?
Palladium with the 4, the aluminum on 4, and then thiosulfate?
Palladium.
Yeah,
Okay.
Sorry.
That's all right. Okay. So is palladium an element or a polyatomic ion? Yeah, palladium is one of those that IUM usually means that, but not always. What? Oh, it's the 4 here? Okay. So we want to go to the, where do we go to find this one? Could be on the periodic table. You might want to look at the one that has the oxidation numbers. Here's a periodic table with oxidation numbers. And I believe PD is palladium, right? Okay. So we have a PD, and the Roman numeral 4 means we have a 4+ charge. We've got to put it with a thiosulfate. Where we're going to find a thiosulfate? Common ions list. There it is. So there's thiosulfate right here. S2O3, 2 negative. Okay. So I got a 4+, a 2 negative. The whole thing's going to be 0 when we're done. Okay, so we need to know prefixes. What prefixes do we put in front? One and a 2. So we need a 1 palladium and a 2 thiosulfate, and we put them together. The prefixes become subscripts, but we don't need the 1. So it's just PD, and then we need 2 of these. So to make 2 of them, we have to put a parentheses around it with the 2 outside because it's got more than 1 element in it already. How ammonium and what'd you say? Ions form? Sure. Okay, well the first thing we need to know is that water autoionizes. Okay? So the Lewis dot formula for water looks like that. I mean, you could make it a lot of different ways to still be correct. This is one way to do it. And when it autoionizes, a small number of water molecules split. The hydrogen is actually going to leave, but it's going to leave behind the electrons. The electrons are going to stay with the oxygen. And so what we get from that part then is just a hydrogen ion. Okay? Well, after it leaves then, the other part that's left is this. Okay, hydrogens came to the bonding when we did the sharing arrangement. It brought an electron there, right? If it leaves its electron behind, just one less electron, it has a positive charge.
Like, why is it a plus between the, right there?
Because we make both of these. We split it into two parts. You know, it's this plus this is what we have left over. Okay? So then this part that remains here with that extra electron becomes that over there. Okay? So that's the first thing. And then you're asking about the formation of ammonium. So ammonia has this Lewis dot formula, and this hydrogen ion is around when you dissolve it in water to form this. Okay? Form up with this. And so the hydrogen ion is actually going to join up right there. That hydrogen ion, even though it left behind those two electrons, it still wants them. It still wants to have the valence structure of a noble gas, and the noble gas it wants to be like is helium, and helium has two electrons. So it'll join up there to get those two electrons, and it'll form ammonium, which is NH4. But that plus charge joined onto a neutral particle still has a whole overall plus charge. So the whole thing has to have a plus charge when you're done. So this is the hydroxide. Okay? And this is the ammonium. So when we put ammonia in water, water already has those hydrogen ions. Okay? So the ammonia starts soaking up the hydrogen ions, leaving behind hydroxides as well. Explain it any way you makes sense. I'd probably have a lot more on there than I would expect you to have. I'm trying to make it make sense to you so you can all repeat, a reasonable amount of it. The main stuff is the part I wrote in black. Well, not even this arrow here. You don't need this arrow. You don't really need.